Good day everyone, my name is Mark Daniel S. Rubio and I'm going to discuss today an introduction about chemical kinetics. But first, what is chemical kinetics? Modern chemical kinetics is a science describing and explaining the chemical reaction as we understand it in the present day. It can be defined as a study of rate of chemical process or transformation of reactants into the product, which occurs according to the certain mechanism, i.e., the reaction mechanism. The rate of chemical reaction is expressed as the change in concentration of some species in time. It can also be pointed that chemical reactions are also the subject of study of many other chemical and psychochemical disciplines, such as analytical chemistry, chemical thermodynamics, and technology. To break down what I'm going to do in this video is I'm going to discuss what a reaction rate is, and I'm also going to point out some of the equation associated with reaction rate. So first, we need to get a good understanding of what a reaction rate is. So when we talk about a rate of a chemical reaction, we're talking about how fast a reaction occurs, and as a result, we usually end up dividing by time. So these two examples here, the speed of your car and your hourly pay, those are both rate because you're dividing a change in some quantity per unit on time. In the case of the speed of the car, you have a displacement delta x and you're dividing that by time. So x in time. And in the case of your hourly pay, you're taking the change in the amount of money you make over unit of time. The hour usually as well. So let's look at another reaction and see if we can learn a little bit more about the rates. Okay, suppose I have the following chemical reaction. Hydrogen 2 plus bromine 2 yields 2 hydrogen bromine. Okay, so on the left side of the equation, you have reactants. Those are getting used up. And on the right side of the equation, you have products. And those are forming as a reaction proceed. So let's sort of look at the concentration of these things graphically. So let's say I want to look at the concentration of hydrogen bromine and the concentration of hydrogen 2 over time. So I just constructed a concentration versus time plot. So my y-axis is going to be time in second, and my y-axis is going to be molar concentration in moles per liter, and the curves resembles the reactants on products. So the blue curve represents hydrogen 2 because the concentration of the reactants are being used up and they are decreasing. And the green curve represents hydrogen bromine because since it is a product, it starts at 0. Concentration increases as the reaction proceeds. So let's say I want to know how fast the concentration of hydrogen bromine is changing. Generally, I pick 2 points to know how fast the concentration of hydrogen bromine is changing. 2 points represents time in molar. 2 molar in 1 second and 4 molar in 2 seconds. The graph shows how fast the concentration as well as its time with the help of slope between the 2 points. The slope of the line is going to be delta y over delta x, where y is the concentration and x is time. So its overall delta concentration is delta hydrogen bromine over delta time. So this is the rate formation of hydrogen bromine. But to know the overall rate reaction, you need to account the stoichiometry of its reaction. This equation corresponds to the following reaction scheme. You have A mole plus B mole yielding to C mole plus D mole. A, B, C, D is the capital letters, are the reactants or product themselves, and the little letters are the stoichiometry coefficient. So this is the equation rate. So based on this equation, there's actually a variety of ways to get the rate. These are all equivalent quantities provided that you have the balanced chemicals equation. So in general, the three things that you need to determine the rate of the chemical reaction are, like I said earlier, the balanced chemical equation. You also need the change in concentration for any reactant or product. Just one will do. And lastly, you need a time interval